This video is on the domain and range of a function. Now we'll discuss what domain and range mean in regards to functions, but let's look at this information first. So I have here, Adam earns a fixed amount of £10 a shift plus an hourly rate of £7 an hour. Now he has to work a minimum of 2 hours, so he can't work less than that, and he can work up to 7 hours a day. Now I can write a function for the amount Adam earns in a day. For that, I need to first say that, so I'm going to say let x be the number of hours he works, so the number of hours Adam works in a day. Okay, so let x be the number of hours Adam works in a day, and I'm going to call the function for the amount he earns in a day f. So my function is going to be f of x. So remember, this is where I input. So I input the number of hours he works, and I want to be able to find the amount he earns. So he earns a rate of £10 in a shift plus an hourly rate of £7 an hour. So he's always going to get his £10 in a day plus £7 an hour. Now, how many hours he works? He works X number of hours. So we have £10 plus 7 times the number of hours. Now, we said that Adam has to work a minimum of 2 hours. So I want you to think whether or not this makes any sense. So if I say, okay, if Adam worked 1 hour, he will earn £10 plus 7 times 1 hour, which is equal to £17. Now, does this make any sense for the function that we want to represent? Well, actually it doesn't, because the minimum he needs to work is 2 hours. So he's not allowed to work 1 hour. So this actually doesn't make any sense, and this doesn't work for us. Now, what about, let's find how much the minimum amount he can earn is. So we have f, so minimum amount of hours is 2 hours. So we've got 10 plus 7 times 2. That's going to give us 10 plus 14, which is equal to £24. So that's the minimum amount he can earn. What about the maximum amount? So the maximum he can work is 7 hours. So we're going to input 7 hours now. So 7 hours. So it's going to be £10 plus 7 times 7, which is equal to 10 plus 49, and that's equal to £59. So the minimum amount he can work is £24. That's when he works 2 hours. And when he works 7 hours, which is the maximum, the amount he earns is £59. Now, how can I write my function for the information I have here for Adam, for all of this information, including the minimum of 2 hours and the maximum of 7 hours, to show all of that algebraically in a function? So let's try and do that now. So I know that the function has to be written as f of x is equal to 10 plus 7x. Now if I leave it like this, it assumes that I can have numbers like 1 here, but I know that we're not allowed that, because he's not allowed to work 1 hour. So just leaving it like this is not good enough. So I need to show somehow that he can work a minimum of 2 hours and a maximum of 7 hours. Now, if he works a minimum of 2 hours, then what we can have is, we know that x needs to be more than or equal to 2 hours. And I know that x has to be less than or equal to 7 hours. Now, all of this we can write in one inequality. We can just write 2 is less than or equal to x, which is less than or equal to 7. So this line here, and this line, they mean the same thing, because x is more than or equal to 2. That means 2 is less than or equal to x. And x is less than or equal to 7, and I have x is less than or equal to 7 here. So my function, I need to complete my function by writing, so let me just rub this out. So I need to complete my function by writing that this has to take values of 2 is less than or equal to x, which is less than or equal to 7. Now this is what we call the domain of a function. This is the domain of a function. So the domain is the values the function can take, and the values that this function can take are between 2 and 7. Now I did also mention the range of a function. Now the range of a function is the output values that the function can give. Now we've worked out the smallest output value that the function can give, and that's £24. And we also worked out the largest output value that the function can give, and that's £59. Now the way we can write that is we can write that in an inequality. So we can say that the range, so the range of the function is, so I know the smallest value was £24, and that's less than or equal to my f of x, because this is what gives me my value, and that is less than or equal to £59. So my range, so the range of my function is here. So 24 is less than or equal to f of x, and that's less than or equal to 59, and the domain is here. Now one last thing that I'm going to do is I'm going to draw a sketch for the function, so you can see how this is illustrated on some axes. So my input values, I'm going to call them x, and my output values, I'm calling them f of x. So the smallest x value I can take is 2, and the largest x value I can take is 7. And when I input 2, I get a value of 24. And when I input 7, so that's there. When I input 7, I get a value of 59. So let's put that there. So that's going to be about there. So my function is between those two crosses. So if I draw a straight line, so a straight line through those crosses represents the function. Now I can see clearly now that my domain is from 2 to 7. I can't go less than 2 because he's not allowed to work less than 2 hours, and I can't go more than 7 because he can't work more than 7 hours as well. So this is the domain, the x values that he can take, and these are the output values I get. So f of x is there, and the smallest f of x value I can get, or the smallest output value I can get, is £24. That happens when he works 2 hours. And the largest output value he can get is £59, and that happens when he works 7 hours, and that's £59 there. So the range for f of x is 24 to 59, and the domain is 2 to 7. So I have that there, and the range, I have it here. Now what I would like you to do is have a go at these questions. Now you're going to have to use your problem solving skills for these, because I haven't done examples like this above, but if you do understand the example above, you should be able to answer these questions. So have a go at these questions, answer them, and then bring those answers to the lesson.